All right. Apologies again. Thanks for bearing with us on that. Just wanted to give a thank you to everybody for showing up tonight, and especially for dealing with all this. Getting started a little bit later than normal, but just welcome to the React Denver meetup. Obviously, if you didn't already get some pizza and beer, I'm afraid it might be gone. This is, I think, our most well-attended meetup we've had yet. And if you're in need of a seat, we can grab some more from either direction. So feel free to meet me out over here, and we can do that. Otherwise, if you're fine standing, that's cool too. I am going to prop open this door here, get a little ventilation going. It's a little hot in here, I realize. So, but just wanted to give a thanks to a couple of our sponsors, Crown Peak and Granicus, both for allowing us to be in this space and host these meetups here. Before we get going and before I introduce the speakers, I wanted to give people a chance to talk about any positions they might be hiring for, any open roles. Anybody interested in, anybody hiring currently, or looking for jobs even?
Hi, I'm Jesse from Craftsy. I'm the manager of front end. We're hiring a senior JavaScript developer and a JavaScript developer. Been doing a lot of hiring lately with 2 positions up there. So if you're interested, come find me.
Cool. Thanks, Jesse. Anybody else? Matt?
Yeah, hi, I'm Matt. I work at Workday. Boulder, we're hiring for a few positions up there, so either like full stack or at least full stack. Level higher, something like that. Do some back on the front end and some middle on the back end.
Awesome. Anybody else hiring or looking for work?
Okay. So, just in case anyone missed it,
Sure. Anybody else hiring?
One second on top of Jesse over at Grass, we are doing a lot more than just our front end. So if you're or if you know anybody, our sysadmin, senior DevOps, back end Java, anything. So some product managers are also.
Cool. All right. I think that about does it. So, okay, to kick things off, we have 2 speakers tonight, as we normally do. But Steve Kinney is going to go over React performance and debugging with us, and then Yoel Tadmor is going to discuss Recompose with us. So, just a quick announcement: if you didn't already know, men's restrooms right here. Women's restroom is all the way around. Unfortunately, I would not recommend going through the glass doors, as you will be locked out. But just go around. Promise you'll find it. There is a water dispenser over in the corner if you didn't already see that, in case you don't want tap water. But other than that, we'll get things going. And so if you would, please give a round of applause for Steve.
Hello. My name is Steve, but we've covered that. I am a senior front-end engineer at SendGrid. So, like, if you get emails, I'm sorry. I don't send those because there's no front end to that. I work on a product basically to help marketers, like, kind of craft, like, marketing campaigns. And so you drag and you drop the stuff in there. You switch over to a HTML code editor. We take any arbitrary HTML that you could have possibly imagined, try to build a, like, complete editor around it, and then try to export something that works with Outlook 2003. Which, fun fact, if you learn nothing else from this talk, you think like IE is terrible, and you're correct. Outlook doesn't use IE's rendering engine. It uses words. It's almost like Outlook looked at IE and said, "Hold my beer." So yeah, that's fun. We're hiring. Sendgrid.com/careers. if this sounds like something you'd be interested in, you let me know. But yeah, it's all built in React, and it is like a very large application, right? It is a WYSIWYG editor plus like everything that Mailchimp apparently does, and all those other things, right? And like you need it is a big app and it needs to stay performant, right? And it comes with a lot of like performance issues. So we're going to talk about how to diagnose some of those. In my copious free time, I also run a conference called Dinosaur.js, and anyone go to Dinosaur.js? All right, nice. And then, I think a lot about writing books. I don't actually write because I don't like writing books. But you can pre-order them today. No promises. All right, so fine print. React is fast, right? Yeah. And it is fast until your app gets very big, right? Because the team that works on React is very smart, but they are not psychic, right? And so the peculiarities of your application are not something that out of the box React supports, right? So for most applications, all of the optimizations that the team has done are probably good enough for you. But there are cases that as you go to medium-sized to large-scale app, you become your own special, unique snowflake of an application, and your problems are uniquely your own. So we're going to talk about how to figure out some of those things. That said, nobody likes the person on their team that blows an entire sprint trying to get an extra millisecond out of a for loop that nobody asked them to do. So don't be that person, right? And also, we're going to look at some contrived examples because this is not my first rodeo. And I know that you've had beer and pizza, and listening to me talk with a super complicated application is not going to work. Also, NDAs and stuff like that. I can't actually show you all the code for the real thing that we work on. And if I had the time to build a fake application as big as a real application, that would just be the thing that I did for a living. So we're going to look at you're why do we need to optimize this app? Noted. Thank you for that feedback. It's mostly because I care, and nobody wants to, at 7 at night, after a beer and a slice of pizza, go very deep into a large application in 20 minutes and hope to feel better about themselves afterwards. Cool. Those emojis looked a lot better. That one was a snoozing face. That one was a person behind a computer. Beer and pizza held up. But I don't know. This is it's my first time using Google Slides. Sweet. All right, so let's also talk a little bit about what do we mean by performance? No. That's what I'm gonna keep talking. All right. Performance means a lot of things, right? There's time to first load, right? And that is how long do I have to wait before I can do stuff on your app? That's a thing, right? It's not necessarily React specific in a lot of cases. That's are you code splitting and tree shaking and minifying? That's a whole long talk on Webpack that we can have another day. What we're going to talk about a lot about is okay, your React app is running. They're using your application, right? How do you make it not terrible? That's going to be our main focus today. So that's not the entire performance picture. I think Google has a really great way that they think about this stuff. It's Rail, which is response, animation, idle, and then page load. That's the L in Rail. Page load. I don't make these acronyms. I just feel sorry when I say them out loud in front of a room full of people. We're going to count more as they're using that. What is the response time? How quickly can we render things in this case, right? The rest of that is all very valid, but we have 20-something minutes together. First of all, before anything else, the low-hanging fruit of performance in a React application is to make sure that you are in production mode, right? What is production mode? And we'll see in a second, but I can see the next slide. Know that my slides are out of order right now. Let's do this. Whee! And so what is production mode? Basically, when you're developing, React tries to be your friend. And it's hey, I would like to yell at you about prop types. Or, excuse me, it's class name, not class. You're okay, neat. All of those things are not very important in production, right? And those things slow your app down, right? So before you go to solve some big performance problem, it's usually helpful to figure out, do you actually have a performance problem, right? Because if it's solely in development, right? All of these extra helpful things are slowing down your application, right? Like, it is true that like an application is effectively slower just by you looking at it, right? Every console log you put in there slows down your application, and the more you put in like different like performance metrics, the more you're slowing it down. So like, if it is fast enough, don't look at it. But this is we have settled that we have a problem now, and we would like to make this a little bit better. Cool. So this is what it looks like if you have the React Chrome developer tools. You get this very angry like orange one with like a little bug in it. That means you're in development mode. So if you go to your production website and you see that, you're not in production mode. Fix that. Before you do anything else, do not pass go, do not collect $200, fix that. What it should look like is this fancy little black one right here, right? And this turns off prop type validation, helpful error messages, all that fun stuff that you care a lot about, but your user does not. All right, let's go back to inspirational quote time now. Cool. So, like, what is the first thing you need to do, right? Yes, it is very, like everyone loves junior developer that shows up and turns every for each into a for loop because they're 50 times faster, and then blows an entire sprint on that. But, like, figuring out, like, measuring first, like, what are the pain points in your application? We'll actually get a chance to, like, look at some of the tooling around figuring out what those pain points are. But, yeah, don't try to, like, solve performance as some kind of, like, crucible that you can, like, wish to have like people worshiping you because you took 10 seconds off of something, or 10 seconds people worship you. 10 milliseconds nobody cares. Cool. All right. Here's just a freebie one. We'll do some like practical ways of diagnosing stuff, and then just like unsolicited advice for making your app faster that you didn't ask for. But we'll start out with like easy ways to measure. So here's like the easiest one right at this moment, which is for like your app or whatever that major like God level component that you have is if it will mount, you start, you could theoretically make a new date, and then like those aren't really precise. If you do like date.now, that's like somewhat precise. But most modern browsers have performance tools built in, so you can mark the time setup. This is for any like any component in your app that you think has a long setup time, right? So again, our major thing that we care about today is response time and just like doing stuff and re-rendering and stuff like that. But step one, if your app is taking, like if you see it, like the AJAX requests have come back and that initial time is too long, right? Like figure out where the pain is. So this is, you can actually performance mark. This would be our app component. We can say like, when did it start to like render and load for the first time? When did it actually mount officially, right? And that gives you a sense, is this where things are slow, right? Because when when you just log onto a slow app, you're like, it is slow. Right? Now it's like, why is it slow? And then, how do I fix it? Right? But figure out what part is slow. Because sometimes it's not the overall app, or a lot of times it's not even the part that you expect. So that's like kind of a freebie. Now let's get to like the actual real meat of this. So my first golden performance rule is like not doing something is way faster than doing something. Even if you do something really fast, not doing it will still be faster. Right? When in doubt, don't do stuff that you don't need to do. That will be faster than doing it. Right? Okay, now like what is the practical part of that? Cool. So like whenever your state changes or your prop changes in a React application, React has this virtual DOM. Most of us, what we know about the virtual DOM is that A, it exists, and B, that makes things faster. After that, it's like a black box, and nobody really understands what happens in there. That's fine. And so again, like yes, the process that React enters in is called reconciliation, right? And it is very fast. But going back to the previous golden rule, what is faster than reconciliation? Not reconciling, right? So when in doubt, if you don't need to reconcile, that will still always be faster than reconciling. So yes, diffing the virtual DOM, quick. Not diffing it, better, right? And so we'll talk a little bit about ways of like skipping this process when we don't actually need it. After that, like React is not a large library. It is a view layer that takes the current state of the world, looks at the DOM, and figures out the differences. Once you've done step one, you've won most of your performance games. You can go home. Like you can basically do that thing where you don't actually like focus the rest of the sprint and then like ship it on the last day and like demand to be coordinated. Everything else beyond that is like regular JavaScript stuff, right? If your JavaScript runs faster, well, I don't know how to break this to you, your React application is written in JavaScript. It will also be faster. So those are like the kind of two things, and like do less of it programmatically if you can. Sweet. So there are a lot of tools that React comes with for tracking what the performance of the DOM is, right, or your virtual DOM. And like again, you do not want to guess at this because you will guess wrong almost every time. What you want to do is measure. And so this is actually some of the output of one of the tools that we're about to look at, which actually takes a look at, and this is literally a method called print wasted, right? And it prints a table of every time you made React do something, and it's like, why did you make me do that, right? And like, again, going to that golden rule, this is the core thing for us to fix. Like, it can actually say, like, I did the thing, it was pointless, thank you. So this actually isn't too bad. Like, we do it once, fine. So when we look at this one, what it'll actually show is like every time you told me to diff, I did it and nothing changed. Don't tell me to do that. And we'll take a look at that in a second. So the performance add-ons are in a library called React Add-ons Perf. One of my biggest pet peeves of programming is when people can't spell full words, but I don't, again, I'm just the one delivering information here. Cool, and so that's how you pull it in. It's got a bunch of methods. We really, personally, I only care about 3 of them. Start and stop, those are important. Like print DOM will show you every DOM thing that it did, every insert, every changing of inner HTML, every removal. I don't care. So that one's like print wasted, and it actually has a an internal method called get wasted. I'm very upset that was not the public API. I think that would have been better. Start, stop, and print wasted are the 3 that we care about. Because, like, yes, you can tell me everything that you did, but I don't care about everything that you did, right? I just care about the things that you shouldn't do. Cool. So the way it basically works is you can kind of pull it in, and you can start out, and like whenever you start, it will start measuring, right? So maybe you want to start when your application first loads, but maybe that's not where your problem is. Maybe your problem is when a certain AJAX request comes back, and you're going to display the 10,000 rows in a table, and that sucks, right? So you would start the performance metrics before, let that happen, stop it, and then see like where things went poorly. Cool. And what we'll actually take a look at is like it might make sense in your application and development to just like have like a floating CSS div with those buttons, like start and stop and like print wasted, right? So you don't have to like programmatically do what I do with console logs, which is unspeakable. Cool. So reconciliation is fast. You know, it's faster not reconciling. So basically, React decides whether or not it's going to try to see if the virtual DOM changed. And what it does is it invokes this method on a component called shouldComponentUpdate. Seems legit, right? This is the default implementation of it in React.component. Should I try? Yes. And our job is to say, maybe you don't. Maybe you don't do that. Like, maybe we don't need you to do it. Maybe I know more about this app than you do, React, because you don't know anything about this app. And, like, we override this, right? And, like, this is, like, this is, like, the most obvious way to speed up your app. This is the easiest one, the one you can implement tomorrow. The one that we'll get to at the end of this talk is, like, the more aspirational one. But this is, like, the easy one, which is make that not true, and it won't do the thing. That does not mean set it to false. Because then you just have an HTML document with a 5 megabyte payload down. Don't do that. Cool. But you could say that, like, hey, the only thing that this component cares about is, like, the text property. Right? And you can see that shouldComponentUpdate gets 2 arguments, the next set of props that it's, like, about to receive, and the next set of state that it's about to receive, right? And you know that this component only cares about like a subset of that, right? So in which way you can actually take a look and see like, okay, the text is the same. I don't care what else came in, right? I'm not interested in that. Literally all this is about the text. So we say, hey, like if these are equal, yeah, so they're like if these are not equal, we'll go ahead and do it, right? That'll be true. If they're equal, that would be I think that might be backwards. Let's go with it. Cool. But like basically, you can kind of figure out the logic of your application. I think that's wanted an or statement in there. Cool. By default, there is a thing called shallow compare, and shallow compare will. It's really good for primitives or objects of primitives, right? Like anything like this. We know that like two strings, they're both the same string, are equal, right? And we'll get to some slides that show that that's not always the case. Shallow compare will just basically look, are these things mostly the same, right? If they are both ones, we'll just no-op this. This is actually, if you know those stateless functional components, this is what these do by default, right? This is what happens in a stateless component. It will shallow compare the two. Now, we'll see later in this talk that that's not always enough to get you, like, yeah, stateless components everywhere. No. I mean, yes, but no. Like, yes, they are wonderful, but no, they are not always going to solve your problem because you could fuck this up in a myriad of ways. Cool. So here we'll see if the props are the same and the state are the same, you know, something along those lines. And the way that this works is, and this is from the React documentation. I didn't make this ugly graph. All right, virtual DOM should component update. Cool. Virtual DOM is not equal. It goes down to all the children, right? And so if you have a big enough application, you can say like here, we're going to say this red means don't should component update is going to return false for whatever reason. Which means React is not even going to check the subtree, right? It's like, hey, if some higher level one's like, I'm good, React's not even going to try to traverse down, right? So like again, not diffing, way faster than diffing. On the other hand here, it's like, yeah, we do want to should component update. It has changed, so now we have to go and look at every single one of them, right? So basically it's a way to like control. If you know that a certain part of your UI doesn't care about a certain amount of state and props, like you can actually like opt out of all of this. Now I will like ruin the end of this talk right now. You know it's even better than doing this? Not giving components things they don't care about, right? That is even better. But in the situation that you have things you don't necessarily care about, or maybe don't always care about, this is a way to kind of like control things. Cool. Shell comparison, really great for like primitives like strings and numbers and booleans and stuff like that because they shallowly compare. But like, this works. And then this is everyone's favorite part of JavaScript, right? Is that like these two objects that are effectively the same are not the same because they have different like memory addresses, right? They are two objects that yes have the same keys and have the same values, but they are different objects in memory. So like a shallow compare would not work out with this. They are not shallowly the same. Same with like arrays or anything along those lines. Cool. Other fun trick that we'll take a look at in a little bit is that if you have the developer tools open and you throw in this query param, you get a whole bunch of extra insight into the performance of your app, right? So the two like high-level things that you can like implement tomorrow are the perf object for diagnosing this and using this React perf query param, and we'll actually see both of those in action when we get to the live coding portion of the show. And it uses this thing called the user timing API, which doesn't have like every browser supporting it. So like if you try this in Chrome, thumbs up. If you try this in Edge, thumbs up. If you try this in Safari, like how are you even using the Safari developer tools? Please explain them to me because they don't make any sense to me. And then Firefox has like planned support, but it hasn't shipped as of my knowledge right now. So I'm gonna be like, yo, they shipped last week. Like, okay, sorry. Cool. That was the David Bowie emoji, and we're gonna like take a look at some code. Again, we're gonna take a look at an app that most likely does not need performance optimization, but it is small enough that after a long day of work and all those fun things, that we can pay attention to it. Cool. Discuss switch. One moment. There it is. This was the speaker note window that I was looking at the entire time. That doesn't respond to arrows. If I looked confused on slides, it's because I was staring at literally that thing. Cool. All right. So let's take a look at our app. And this is just a very simple create React app. We're naming. All right, server starting. My app is not that bad. And when we take a look at the code, what I want to show you is that like one thing that I'm very good at accidentally making slow applications. Do you know what is borderline impossible? Purposely making a slow application. Like, it is impossible. Try to go out of your way to make like a server-side app with a security hole. You can't do it. Try to accidentally do it. It's super easy. Cool. So it is, you know, like making a to-do list is old news. So I did not make a to-do list. I made a packing list. Things, and we can say like, what else do I need to bring on this trip? Not everyone at once.
Shoes.
Shoes, yeah, that's good. Sweet, you can add it. You can like mark stuff off as packed or unpacked, and the idea is that when you get home, you can like mark everything's unpacked and get ready for the next trip. Cool. You can also like remove stuff. You can see I have this little start profiling thing down here. Now we'll take a look at the app real quick. Those are just the settings. Sweet. So this is the application component. Yes, it has some default state because I'm not really using a real database. So if I hit refresh, we start over. And we have this like default trip time function. Other than that, it's like your average like React application. Like it's not purposely slow. I didn't like go like, hey, don't do this ridiculous thing. It is like the application that you would just like normally write. We'll cache some methods. We do have this countdown which says when the lift is coming. Sweet, you know. We'll clear that, like we'll actually clean up after memory. We have our, when it renders, we'll get our list of packed items and our unpacked items, and we'll show them. We have a marked as packed that toggles it. We have a remove that like filters it out. Nothing to see here, really. Items list and item are actually stateless components, so there's not a lot happening there. We just pass it on through. And then the only other component that means anything is new item, and new item does everyone's favorite thing, which is have an input field. Every time the input field changes, change the state of the component, right? That thing that we've all written 1,000 times, we don't understand why it's not already in the framework. That's what's happening. You can see I made one half-hearted attempt to use Flow before I ended up in my normal case of just hating Flow. Like I like Flow in theory until I'm using it, and then I don't, because it's just yelling at me, and I don't like that. Cool. So let's go ahead, and what we're going to do is we're going to start profiling, right? And I'll do some things. Maybe I'll like check some stuff back and forth. Neat. You can see that like we have this ridiculous timer that's always updating, and we'll stop profiling. And all right. So this is the print wasted, and you can see like new item like rendered 25 times. Why did new item render 25 times? Right, even my list of items, right? The two like counts and that's the countdown clock. That should have gone a bunch of times. 5, that makes sense for the items. But like the first thing I'm noticing is new item should not have rendered 25 times. Even when we started profiling, we didn't do anything with it, right? Then we want to take a look at why it rendered 25 times.
Is it rendering when your counter's ticking?
Rendering my counter ticket is also rendering whenever I'm changing the list of items. It's rendering all the time. Because should component update? True! So we do it, right? And it's like nothing changed, right? I don't care. Neat. So what we'll do here, and there's some other problems with this app. What we'll do is we'll take a look at this one right here, and we can say, hey, what is the only thing that we actually like care about in this input field? I cheated. I highlighted it. Yeah. All right. So like, if the value of this input field hasn't changed, do we need to re-render the component? Nah. Like if it changes, yeah, we need to show it in there because input fields get very angry in React if you don't update the value. Cool. So we'll do like should component. I had to triage an issue at 3 in the morning today. So like one, if you're talking to me after this and I look like I've either had like a minor stroke or something like that, I have not. I am just tired, but also I need live coding help. Cool. And so what we'll say is we'll return. So we know it's really the state that we care about. So new props, new state is the other one. And if it's only if this dot state dot value does not equal new state dot value, right? Because like, hey, like if they don't equal the same thing, yeah, re-render it. But if like they're the same, like that's literally only you have one job, right? Cool. So we'll save that. Nope, we'll not save that. All right, we'll start profiling, and we'll just wait for the countdown on this one. All right, cool. The only thing that changed, right, was the countdown. And like, you're like, that wasn't wasted. Well, we have it going every 500 milliseconds, and like, the second hasn't changed every half second because that's not the way seconds work. So I could try to do it every 100 milliseconds and stuff like that, but like, there's a reason for why this, like, then you'd have to time it perfectly. I'm okay with this little, like, every little bit of waste every like half second. That's fine. We're not going to optimize any further on that one. Turns out though, that there's still a little bit more work to do here. You'll notice that, like, why was it that new item updated, and we still have this, like, kind of issue where it's like, shouldn't, like, the items been doing that as well, right? Like, they're hearing this countdown timer as well. Well, we have some problems, and we can actually go ahead and take a look. We do this question mark. And so this, you know, under question mark React Perf, we'll go ahead and we'll look, and I think it's under performance these days because every release of Chrome, they move it. And so we can see this is going. Cool. Yeah, that's probably enough. And all right, let's zoom in a little bit. And you can see this is not a big app. We have these like little, looks like every half second changes. So far, nothing to be alarmed of. You might say, I'm going to now do the pinching motion on my MacBook to zoom in. You will not. You will scroll down. All right, here we have it. This is now, this user timing is React specific. This isn't the normal craziness like when everyone shows a flame chart just to like prove that they're smarter than you. This is the actual one that's hooked into React. And you see application, fine, that makes sense. Like, you can see the countdown, that should have updated, right? And then look, items is updating, and each item is rendering again the whole way through. Like, they don't need to. That is silly, right? Why is this happening? Want to take a lucky guess? Because I tried to be a hero, and I'm making 2 brand new arrays every time I'm in the render function, right? And so those arrays, are they equal to the arrays of last time? Even if there's the same items in them? No, because like 2 arrays with the same items aren't equal. And those objects aren't even equal, right? Because they are technically different objects in memory each time. Because these are like, they might be the same objects, because I don't think I'm actually changing them. But they are brand new arrays, right? And so a way to have yourself render faster is to stop doing stuff in the renderer process, right? So for instance, if we actually took care of this, like, hey, when it initializes or when it receives like new props or something like that, go ahead, right now, make me the list of packed items and unpacked items, right? Do that outside the renderer process. Now you have them in state. If those arrays have not, if you have not changed those arrays, are 2 of the exact same, like, if you say like new array equals A and say B equals A, those are now the same array in memory, right? And if you do that, what you'll find is that now you will not re-render them all. Because React's like, that's the same array that you gave me last time. And it's not going to re-render all of those items, right? So like some of the, and that's just like, that's because like memory in JavaScript. So one, taking stuff out of your renderer process that you don't need to do, like keep that in a method. Like it's like sometimes I think a lot of us, even like on the functional programming side, is like methods on classes, that's like so 2016. And like it also does a little like object-oriented programming. Objects hold on to state. It sometimes makes sense, except when it fights you. And then it doesn't. And then you swear it off. You're like, I'm only writing Haskell from now on. Cool. So let's go back. That's kind of like how we can diagnose. So like looking at like the flame chart, if you do the question mark React Perf, you can actually see the rendering process and see if you're doing unnecessary work. And like there's no way that React could have figured that out for you. You know whether or not something's supposed to be happening or not. Cool. Other things that we could have done is we could have said like, hey, get the new time, right? In that count interval thing, get the new time. Only set the state of the time if it's different from last time. That would have gotten us down to once every second, right? There's a lot of like little performance gains here. We don't have a lot of time together. All right. So again, thinking about those arrays and the fact that they were different objects, right? Don't ever do this is unsolicited advice time, right? You didn't ask for it, you're getting it. Which is to bind in the render component or to use an arrow function. Does anyone know why? You're passing a brand new object every time as a prop. Guess what? Like React's like, new props. Let's re-render the world. You're like, yo, it's the same thing. Chill. Right? So if you actually do that like little like disgusting thing in the constructor where you say like this dot update equals this dot update dot bind this, then it's the same one over and over. If you make it a method on that class, right, they will be the same ones. Or if you just have it as a stateless component and it was from a higher level, that will work. But if you make new objects in your renderer process, guess what? React's like, I don't know. I don't know that these are different. I have to figure it out. And what takes more time than figuring it out? Or what takes less time than figuring it out? Not figuring it out. So do something where you either keep it in a method or do that thing in the constructor where you make the one function you're going to use over and over again because now it's not a new prop. Because even if you wrote the most, hey, have the props changed in my should component update? Effectively, they have, right? Like, not spiritually. Well, yeah. Not like the way you didn't want it to, but they have, right? Cool, so don't do that. Also, performance optimization is boring and it sucks, right? So don't do it. You're like, why am I here? Like, let your build tools do it for you. There are things that we can use, right? And sometimes we only want them in production. So it's not like write your code a special certain way. No. Whatever. Write your code a special certain way. It's like write your code in a way that your coworkers can read it, and let Babel take care of all this BS, right? So there's a bunch of interesting. This is a tool called Why Did You Update, and it's kind of like the Power Tool version of those perf tools that we saw before. It's like if you gave me the same props again, I'm going to yell at you. And that is a great way to build like rapport with your coworkers. It's just like install this in like a really big PR, and like don't make any mention of it, and now it's in there. You can do this ESLint rules. It's great. Like you just install whatever your preference is and just hide it over the course of like, just like Stockholm syndrome. No, it's always been this. Cool. There's this other one, React. This again, the reason you put this in the build process is because you only want this in production. You don't want this in development. What this does is it looks for all the time that you made a component that was just like a div with the same class. And rather than instantiating 100 of these, it'll actually just rewrite your code, hoist it up to the top, and you can refer to the same object over and over again, right? No. Don't worry, it's just screenshots of Babel pages. The other one is calling functions is expensive. They add a function onto the call stack. You have to run it to completion. You have to take it off the call stack. That's why a for loop is technically 50 times faster than for each. Is putting those functions on the call stack that is slow and instantiating them. So this is what happens if you write Babel. Are you all familiar? I'm sorry, JSX. Are you all familiar with JSX? Sweet. I'm at the right meetup. Which is that transpiles into React.createElement. For those of you keeping track at home, that is a method, right? It adds to the call stack. As of React 15.4, your very, very simple components, your divs, your H1s, can actually be written in just like a regular like object notation. Whee! Like this, which involves not calling a method, not adding something to the call stack. Nobody wants to write this. I mean, somebody wants to write this. Someone's like, I'm in. Let's do this. Right? What this plugin does is in production, you write this. Babel does this. So you get to have the performance gains, but you get to like keep your sanity in the process. Rarely does programming work like that. Because somebody who works on Babel decided they were into it. And there's other things that you haven't seen, like prepack. Prepack goes ahead and like tries to make your code the most efficient way possible. Now this is bigger code, so if you're also trying to minify, good luck. But it will do is like instead of like running over loop and trying to do stuff dynamically, it will just give you a static version of it that will theoretically perform faster once it's loaded. But it's the same basic idea. Cool. Other just fun facts, like whenever baby's first React app, they're like, we don't mutate objects. We don't mutate objects because how do you know if it changed? Totally. So then it's like, okay, brand new stuff all the time. Deep clone all of your objects, right? But what does that do for component should update? Or should component update? Like brand new object with the same data. So like, be careful with deep cloning, right? Like, you don't always want brand new stuff every time. You don't want to mutate stuff, but you don't need to replace everything every time. Just replace what you changed, leave everything else the way it was, and you'll be happier. So some practical tips if you use any kind of state management, which is, again, the should component update, right? It will try to help you figure out which props and state you don't actually care about. Do you know how you make this better for yourself? Don't give components things that they don't care about, and then you don't have to do this, right? You theoretically might not need should component update at all. So here's a quick I'm using Redux as the example here, but it doesn't really matter, right? So here is, hey, we're going to have this container component that's going to pass in A, B, and C to this big component that handles everything and passes everything down, right? But now, anytime A, B, or C change, big component has to change, and we go down the tree. Versus if we wrapped the little components and make big components stupid, A is isolated from B, is isolated from C. So if A changes, only connected A knows about it and is alerted by it. And B and C, which are subscribed to the store, didn't even find out. They're like, A changed? Oh, all right. They're not there's no should component update in here. They weren't even told. Right? They weren't even invited to the party. And to do that a lot of times, keep your data flat. Right here, anytime you needed a user, you'd have to get all the articles, all the comments, so on and so forth, right? If you have these big nested data structures, it becomes like this all or nothing thing and very difficult. Versus if you keep everything very flat, you can give every component just what it needs. If you give every component just what it needs, you don't have to figure out what it doesn't need. You get to go home early for the day. Instead of writing a should component update in literally every component and hoping for the best. So this is just what I'm going to talk through real quick. It could be okay, I have this big list. One of them could be selected. It makes sense to the way I would have written it a year or two ago is, hey, each component, I'm going to pass you the selected component. If you two are the same, right, then you are the selected one. That makes sense as code to write. I wrote it, unless you're better than me. I'm better than me now, but you might be better than past me. Fine, it's fine. Versus now every single one, every time that selected item changes, all 100 of them have to be told about it. Am I the new selected one? Am I chosen? Right? Versus if you do this in either Redux or your state manager before it gets to that component, you'd be like, hey, I'm going to find out if you're the right one. I'm going to pass you a true or a false. Right? The new selected one finds out, I'm true now. Change my CSS classes. The previous selected component is I'm no longer true. And everyone else, they got false last time, they got false this time. They don't care, right? And you can actually save rendering hundreds of items over and over and over again by just giving the simplest piece of data in there. And then, I don't know if you've read the React license, but you're actually not allowed to give a talk on React unless you have one Dan Abramov tweet on it. So this is the kind of ending moral of the story, which is, measuring with the perf tools and the query param, awesome, right? Definitely measure. Should component update will solve a lot of your problems. But again, kind of where we ended on this, is thinking deeply about how you're structuring your application. Is not necessarily performance. You get performance optimizations as a freebie, as well as an application that you thought deeply about the architecture of, right? There's myriad good things about that, right? But a lot of we can do all these little hacks, but giving components only as much information as they need and no more, right, is going to speed up your app a lot. Measuring where it's slow and figuring out, is there a simpler piece of data that I can give in there, is going to help out a lot. I don't have the preview anymore, so let's see what the next slide is. Hey! That's what I just said. I'll leave it here for 1 second to let it sink in and give it some silent gravity. All right. Thank you very much.
Cool. Thanks, Steve. Anybody have questions for him while he's still up here? Wrangle him? No?
Harass me, yell at me.
Awesome. Well, thank you very much, Steve. While we're kind of in the in-between between talks here, I'm going to give everybody a chance to take a break, go grab some water, take a restroom break, whatever you need to do. So let's plan on reconvening here in about 5 minutes, if that works, and we'll kick it off with Yoel's talk on Recompose. Thank you. As usual. This example, literally, that's half of my talk.
Yeah.
Can I do this with stateless components? I'm like, literally half of my talk. I was like, we'll see. We'll see. Hello.
It's just not working too hot. Thank you for doing that. Did it? Yeah. I think it's fine. But as far as like, yeah, that's where it's the auto focus. That's the video encoder in there. Working out some kinks.
Doing well, Jeff. How are you? Yeah. Some of your team doing that work? Yeah.
Oh, nice.
Hopefully, my team does React.
Awesome.
React is this yeah, I actually like our like I can see that now. So actually there's part of it. So maybe it was just hello. Just came together and then we've been like training people. It's like, well, that doesn't really help our dynamics. Yeah, I've used like a couple of I used to use and backbone was just like that was kind of yeah, it'll tell you how to do it. You don't have to
I was like, how can I get this shit to Well, that was the thing. Bullshit. So they kept trying to like make it as slow. I'm like, no, I'm just gonna let it happen. And like trying to make it that slow. I put that in like a separate component, just like out of the heat. And I was like, no, you know what? I'm just gonna start and stage for that. That's what I did. Yeah, I needed something. Yeah, actually, like, my suspicions but I'm going to. I think I might start. Alright, let's get to it.
Anyways, I'll see you tomorrow. See you again.
It's so cold in our building.
Yeah. I was like, I can bring actually, it's like 90. Yeah, and I'm like, I step out, I'm like, I look at this. I would get on this.
Yeah, yeah. Right? This is yours. So I'm
I mean, I do. Make sure. Yeah, that's Is that gonna work? Looks like it. Cool. I'll check it. Yes. Yeah. Sounds like you're just like, I know, it's like you're well, you think about it, so we're almost 15 before, and that busy goes up to like 26. I guess it's 38. I think like the first couple of boys of this movie, it's like the whole Cool. All right, everybody. I think we're gonna let Yoel get going here in a sec. Get your attention. Yeah.
I appreciate that, though.
Yeah. Just a few announcements before we get going with the second talk. React Denver is always looking for speakers, so if you're interested in giving a talk, whether that be in a month from now or 6 months from now, come chat with me or Will here, wherever he is, back there. Feel free to chat with one of us. We'd be more than happy to get you steered in the right direction as far as topics or ideas you might have if you're interested in, like I said, presenting. We would love to have you. So outside of that, there are a couple announcements. Where is Andy? Andy, here we go.
Yeah, sure. I have 2 shirts to give away. First person to guess what that means. That is on the shirt. Free proxy. Close. Come on. Reverse proxy. There you go. And if you want the other one, whatever. Yeah. It's from Section.io and their competitors. Everybody uses like a CDN. What do you call? What do you use? I'm using Amazon. Amazon. What's another popular one? Popular. There you go. They're men's largest too, so that worked out well. For everyone though, I also have prepaid codes for a year subscription at frontendmasters.com. If you've never seen Front End Masters, it's a great site. There's stuff on React, Redux, D3, Node, plain JavaScript. Ask Daria, she likes Front End Masters too. Just come see me afterwards, and I'll give away like 10 or 15 of them. Especially if you're in boot camp or Galvanize or Turning, I'd love to give those away to you guys. So just come find me.
Steve,
Yeah.
you're on there, right?
Yeah,
There
Steve,
you go.
of course.
There's an Electron one in March or November. React pilots are actually doing a progressive development on Friday.
There you go. You can watch that live. Cool. Yeah, thanks, Steve.
Awesome. Thanks, Hank.
Yeah, sure.
Yeah, talk to him. Cool. Well, with that, like I said, if you didn't catch it earlier, we're looking for speakers. Come chat with me. Other than that, though, I'm going to let you all take the stage here. So please give me a round of applause.
All right, so yeah, I'm Yoel. I'm a full stack developer at a company called Umbud. We're right next door, and I spend most of my time doing React work, and very happy to be here giving this talk, and especially happy to be giving it right after that last one, which is not only very entertaining, but actually could not have segued more perfectly into this talk, because a lot of what I'm going to be talking about is this library Recompose, which actually gives you a toolkit to implement a lot of those performance enhancement type things very easily and without having to kind of stress yourself out. And for those of you who haven't seen me give a talk before, which is probably most of you since it's been a while, my favorite genre of talk is me live coding a really, really terrible slideshow app. So this is my really, really terrible slideshow app. There's not that many slides because I'm going to try to just sort of give an introduction to some of the concepts and topics, and then get into the hopefully successful live coding second half of the show. So basically this talk is going to try to cover these questions. What is a state container? What is a higher order component? Why might we use higher order components for state containers? And really, why would we use either of those in the first place? You can see the navigation here is superb. We'll try to get that better later. So what's a state container? This is my definition. I didn't copy it down. Dan Abramov, a long time ago, I didn't link to it or anything, but since I have to mention him, apparently, I'm gonna say he wrote a really good article a while back about smart and dumb components, and you can think of your state container as sort of a smart component. So this is a really quick example. You can see that this component is in charge of maintaining the mood. Right now, I'm happy. I haven't started live coding yet, but once we get there, in case I need to change it to disaster is imminent, I can do that with this method, update mood. But then my render output, there's no actual HTML here. I'm completely punting off to some other component that I haven't defined here, but it's my mood displayer. So I don't know, maybe it just shows a smiley face if it's happy, maybe there's a whole thing, maybe there's animation, I don't know. That's not this component's job. It's just maintaining the state and providing a method to update that state. If you use Redux, right, you can think of Redux as your whole app state container. So just a couple notes about this. The state container is not the same as a higher order component, which I'll define next. And this particular state container is specific to a single render output. So it maintains state, but then no matter what, it's rendering this mood displayer component. So a more flexible state container, there might be some kind of way to say, sometimes I want to render one kind of mood displayer, sometimes I want to render some other component that has more stuff going on but needs to know about this mood problem. So I'll close this slide. Apparently this will be cut off, so we'll try to make do with that. So this slide is, which you can't read the title right now, what is a higher order component? And that is basically just this is a more technical definition. It's a function that takes a component class, so not an actual rendered element, but a component class, and returns an enhanced component. So when that thing is going to get called, what it actually creates is something that you passed in, but with a little bit of extra. And that almost always means that it's enhanced with some extra state, maybe state management tools, but not always. You could write one that, like, you could pass in a component and it would render your component, but would also render a toolbar on top or a menu on the side or something like that. That would also be a higher order component. And sort of like the typical example here, mostly cut off, but the relevant part is this. This is a higher order component, the connect function that Redux exports. So if any of you guys have used Redux, that's like probably the most common one that people who are building production level React apps might be familiar with. And what Recompose basically is a library full of these higher order components. In fact, if you go to their GitHub, you can see in these API docs a higher order component, right? So if you want to read it again, that's where it is. So before we get into live coding, and I'll try to weave in some of what we heard from the last talk in both this and the next slide. There's a few sort of high level, these are abstract benefits of using state containers and component enhancers. One is you're just less likely to have a component that does too much. When I first started writing React, I had a lot of component files that were like 500 lines long, and it was bad. And now I'm less likely to do that. And being able to just split off just the state and the render stuff is already getting you away from having a 500-line file that gets really hard to read and change. On that note, you're less likely to create bugs when you refactor code that's really tightly coupled and you realize that you actually need to support use cases that require you to uncouple it. So maybe you have a visual component and the state is being managed in a certain way, and then you realize, oh, we have another use case somewhere else in our app. We want to be rendering something like this, but we need the state managed in a completely different way. Now I need to refactor it, but all this code is tightly coupled. It's in one component. It's referencing itself. It makes it difficult to refactor. Whereas if it had already been split off in the first place, there might be parts of it that don't need any refactoring at all. That makes it a little bit easier. And on that note, modular code, so if you split off your state part of it from your rendered visual output part of it, modular code can be reusable, or at least, and this is, I find, often just as good, copy-pastable and then change a little bit. Whereas if you have a component that's 500 lines long, the chances of you being able to copy-paste any 10 lines of it into another component and it not breaking immediately, very, very low. Chances of being able to, as you'll see later, like copy-paste a recompose enhancer, very, very high. So even if you're not actually reusing code, you can at least lift code from one part of the app and just quickly use it somewhere else. You kind of know what it's doing, and you get what you're looking for in a minute as opposed to like a really frustrating hour. Let's see if... So here's some more concrete benefits, and I'll try to show these as we go into the live coding. So some examples of things that I've come across where it's been useful to do this sort of decoupling are places in our app where we had a form that was doing, you know, if you think about it like one form, it kind of looks like just one thing, but really that form's doing at least 2 and probably 3 things. One is it's rendering a bunch of inputs. And 2, it is maintaining the state of those inputs. So like, what is the current value of that form? And then 3, there's probably some buttons that let you submit the form or cancel out of the form. And those are doing something with that value of the form. So there's really like a few different things that are going on. And sometimes maybe you want to preview the form because maybe it's your app is something that lets users modify the way their forms work. Or maybe you just want to show the way that something might work in like a sort of like a help tour or something like that. So you don't want to have the same state management, but you do want to have the same inputs. Well, that's an example where if you split those up and you just have your input part and all of your state management submit stuff somewhere else, it's much easier to do that. Another really good common example is components that are making their own API calls, loading data, setting it to local state, and then doing something with it. A lot of times you might render these components a few different times. Maybe that's like there's a few different ways to get there. Every time that component gets created, it's going to reload that data from the API, even if it was just loaded 10 seconds ago. So again, if you split that up into like a visual part and a load this data from the API part, not only can you load the data from the API separately somewhere else, but also that visual part can just be rendered in a way where if the data's already been loaded, it doesn't need to go do anything else. It's just getting that data, and it doesn't need to know about how or when or why that data was loaded from an API. Number 3 here is some quick, easy code paths for perf wins, and those are specifically the ones that we just heard about. So I'll show you guys about how to not recreate new functions every time you render a component, and how to make sure that component relevant state, like am I an active item in a list, doesn't get recalculated every single time a component renders. These two, I put them last in the list because they're not like huge issues, but for me, one thing when I refactor a component and it's something that has some visual parts but also a bunch of state management, you end up finding that in your render function, or sometimes you'll have a bunch of render functions, there's a bunch of references to this.state, or like this.update mood, this.whatever. If you end up moving some of that into like a purely functional component, or even just moving something like the mood that used to be in local state into some parent component somewhere, you find that everywhere that you're referencing this.state, you actually need to be referencing this.props instead, or this.props.update mood. That can occasionally cause kind of subtle bugs where maybe it's not caught by your linting tool or whatever, but you end up with a stale reference to like a method that doesn't exist, or some state that doesn't exist on that component anymore that's actually coming in as a prop now. And it can be a little annoying and sometimes occasionally hard to track down why that happened. Whereas if your render functions are just all props, then you never really have to worry about, like, again, copy pasting some of it, moving somewhere else. Everything's coming in from above. And again, this last one can be a benefit, but sometimes you have things like the active or selected item in the list, and you might call that like active list item in one place in your app, and active item, and active thing, and sometimes, you know, it just gets a little confusing. It's nice sometimes to create just like a consistent interface. So if you do have a reusable kind of state container for things like that, you can find that it's easier to remember, oh, it's always called active list item or active list index or something like that. And every time you're writing a component that uses that, you'll always have the same prop, you'll always have the same method to update it. That can be nice. So that's that for this. Now we're going to get into the code that I used to create this like tremendous slideshow app that I hope you all come to use in the future. Right, so this is obviously a very simple app. I don't know if we could see the timer over here. Oh, okay, it is there. So great minds think alike. I also decided to put a timer in this app to have the entire app needlessly render every second. That's really the only way to do it. Great idea for all your production apps also, by the way. So this app here, this is the main app component. You can see here, this is just it maintaining the state that it then passes down into this timer, but is also re-rendering every second. And then I'm just rendering my slide list. My slide list right now is actually a very simple component, and that's because it's not maintaining any state. Whereas my slide component, which I've written here is like the ES6 style class components, it's maintaining the state for whether the slide is open or not. And you might immediately see that that's like potentially not a great UI, because I can have all my slides open at once, which is a little confusing. But also, it's not great in the sense that my list might want to know about which slide is open and which slide isn't open. Maybe I wanted to like write a header saying, hey, you're on slide number 4 out of 7 or something like that. Well, right now, my list doesn't know about that. So I would have to put it in my slide component if I wanted to render it at all. And that's a decision you might make, but what I'm going to try to do is refactor this so that just at a bare minimum, the app works exactly the same way, but that state is going to be stored in my list component. So here goes. This is water, by the way, so but for dramatic effect. So the way that Recompose works is it has a bunch of just methods, and you input them one at a time. I hope I've installed it. So when I'm writing this, at least anyway, what I like to do is I have these, like, this is a functional component. I'll change it to something called display. And then I'm going to start writing my enhancer. It's going to be something, and then what I'm actually going to like export from this file is my enhanced list display. But frequently, again, I'll also just separately export that display. Again, just in case, right? I've split my concerns here. I'm going to have some state somewhere, but in case for whatever reason some other part of the app wants to use the list display, but in a different way, that's freely available, right? It just that it can do that. So I'm going to compose together a couple things, and compose is one of the things that comes out of Recompose, and it's nothing special. All it's really doing is you give it 1, 2, 3, 4, however many enhancers, and it combines them all up into one function that takes your component and returns something a little more special. And the first and definitely one of the most like common, useful of the Recompose enhancers is called with state. And all that's basically doing is it's saying you want some state, and I'm going to hold it in a parent component for you. You give it 2 or possibly 3 things. So I'm going to do this. So what I've basically told it is, all right, I want whatever component I give you, I want it to have like a parent component that's going to, 1, maintain a state called active slides. So you can think of this as if I was to write that would be like this. And the initial state is this third variable here that I've passed it, which is I'm just going to give it an empty array. Again, I'm trying to recreate the same exact functionality we have. It's possible that there might be 0 open slides. It's possible it might be all 5. So I'm going to have it be an array for now, and that's why I called it active slides instead of active slide. So I don't want to do this, so I'm just going to try to use the Recompose helpers here. And now I'm going to use I'm actually going to leave that be. So now my display is actually going to be given these 2 extra things as props. So this update active slides is just a method that updates that state. You give it a new value and it updates it. And then I'm just going to pass those right through right now to my little slide component. And now here, I even went through the pain, and I don't like doing this, of like littering all kinds of this and this.state and stuff in my render function to give you just a little walkthrough of why I don't like doing this and why it's kind of annoying to refactor. I'm going to try to rewrite this now as like another simple functional component that's also going to get enhanced. So there's going to be some props that come in here. And really, I'd like to just return that same thing. Except now we see all these this.state, right? So I need to go through like all of these here. And okay, so I know collapsed is something that I want to have coming in. And okay, I see a this.toggle collapse, so I want a toggle collapse that's going to be coming. And I got this.props, well there's no this here, so it's not super annoying, but I find it annoying, and it's, again, easy to kind of make mistakes if you need to go through and like remove that kind of thing. So I have my thing, except I don't actually have a toggle collapsed or a collapsed prop, right? What I actually passed in are these update active slides and active slides, right? It's an array of like which slide is which. So now what I need is some way to take those props that I've gotten in and convert these into collapsed and toggle collapsed. So I'm going to use a few more recompose helpers here. And these are two of them that are really, really nice for doing some of those performance enhancement type things that we just saw. In fact, they basically do two of the major ones that we just saw. So again, I'm going to do slide display. So what with handlers does is it basically, you give it an object with a bunch of methods, and it will then pass those methods as props to your wrapped component. But the nice thing is, no matter how many times it gets rendered, no matter what new props come in, you only get the same function every time. It creates the function once, and that's the only function that ever gets passed in. So you get that whole, oh, I don't have to like recreate this function at render time as a guaranteed perf win. The other nice thing, though, is that when that function gets called, it always gets passed in the current props of that component. So you can sort of bind that function to whatever the present props are without having to do too much in the way of like special logic yourself. So the method that I'm going to need is this toggle collapsed thing. So the way that these work is this first thing is going to be my props, and then this is what actually gets passed in. I know it's just going to be a click handler, so that's just going to be that click event. But over here, when the function actually gets called, I have access to that prop object, and that's the props when that function gets called, not when the component is first rendered. And again, that's kind of nice. So if we recall from my list component here, I got this update active slide. So yeah, okay, it's a slide. So I know that one of the props is the slide that was passed in to this particular slide component. And I know that I'm going to have this array of active slides. So the first thing I'm going to do is basically say, like, is it collapsed right now? Because I'm toggling it, so I'd like for it to be the opposite of whatever it is now. And then, I should just do this. So if it is collapsed, all I want to do is add this slide to the ones that are open. And if it's not collapsed, then I want to take out the slide from the list of collapsed ones. And then I'm just going to call, what did I call here? Update active slides. And my other really kind of nice thing is, now I could, instead of, you know, having this collapsed prop, I could try to do something where I say like const collapse. Let's say I was to pass in my active slides. So I could do that. The problem with that is this means this thing gets called every single time this component gets rendered, right? And remember, I have a timer running because I'm not really good at performance enhancement. So this thing is getting rendered every second, and every time it gets rendered, it needs to do that calculation. Now, doing an index of, not going to be that bad, But again, when I was first starting out, I'd have a lot of render functions where before you even got to that return statement, there was like 70 lines of array and object manipulation. And a lot of it was pretty wasteful because it was the same prop that was coming in, but it was just getting filtered and mapped over and like turned into something new that was actually what I was going to render. Well, I don't like doing that. So we have this with props on change. And what that basically does is it says, first you give me a list of the props that I should be checking against. And here, the only thing I care about, I know that this slide's never going to change. Let's just say I know that. I wrote this app, so I do know that. It's always going to be getting the same slide. The only thing that's going to be changing is that array of active slides. And so what I'm telling it is basically, if that active slide array didn't change, don't worry about whatever calculation is going to come next. You don't need to change it. You can just return whatever you had before. And then the second argument here is just a function that takes the props that are already coming in and is going to return some new extra props that I'm going to pass in. And so here, I'm just going to do this. So again, I've achieved the same effect, but instead of calling this every single time I'm rendering, and again, without like a whole lot of code, the equivalent of this would be if I wrote component will receive props if next props.activeSlides not equals this props, this.setState. Like, the code would take just as much room to write, if not more. I basically am able to cache these potentially complex calculations and keep my actual display component really nice and simple, right? I don't even need this return statement here. You know, I could just do that. I'm never going to need to. There's not going to be any other code that happens here before I return. This is really just a function that returns some stuff. And now, hopefully, you try so hard. Oh, yep. And actually, I want to enhance it. Aha. Yay. Okay, so that's going on, and that's pretty cool, right? But what I'd like to reinforce is what's even cooler about the way that this is set up now is that all of my two components that are doing the rendering here, the display is completely split off from the state portion of it. So all I need to do, let's say I decide this is actually a really stupid way to do a slideshow app. Only one slide should ever be open at once. Now, this part's a little unfortunate because now I've basically changed this a little bit to where these are different props. So I'm not trying to suggest that when you like disentangle a little bit, it'll always be disentangled, right? I've tried to write a different enhancer, but now it's going to be trying to pass in different slides. So I need to like rename my prop a little bit if I want this stuff to work. Or I could have tried to keep it the same and had just like some misnamed props. So what I'm basically trying to achieve this time is instead of this active slides thing being an array, I just want it to be one slide. So this is now going to be active slide, and this is going to be a little easier. It's just is active slide is slide. And So if it's already collapsed, then I'm just going to make the next slide is just going to be this one. And if I'm just like closing the slide that I'm already on, then I'll just make none of them active. And now with this one, I really don't have to touch this thing at all, right? My slide is staying exactly the same. It has a button, whatever. I've changed the way the state is maintained. And I would like to refresh this because everything is now an array. Or possibly this code is just broken. This trick always works. Oh, wow. Create React app is like really a special piece of code. Let's go in here and try to see what's going on because I wanted to show this anyway. So one of the things that, depending on your perspective, can be either a good or a bad thing about Recompose is it is going to do quite a number. This thing really doesn't want to. Okay, it is going to do quite a number on your component tree. So you'll see basically what actually ends up happening is my component that used to be just that list display has been turned into with state list display, and it has a state value. And I can see that my slide display is actually this thing that has been wrapped twice now and is actually producing multiple multiple components. I think personally I feel that this is a bit of a drawback with this library, and I know that they are attempting to change some of it a little bit. The advantage is you can sort of separately go through and see the actual like state values and the props that are coming in, so you can try to sort of follow the props down through your various enhancers. If you're like me and you occasionally go crazy and compose like 7 or 8 of these things together, which is probably not advisable, you can sort of like try to go. On the other hand, your components tree are going to go like this immediately for a simple component. And it also means that, speaking of performance, create like React is creating a new element every time, and sometimes you're wrapping your component once, but it's actually creating 2 or 3 parent elements. And when you see that, and if it is a component that you're rendering many, many times, that can be a performance hit. So use with caution. So that was mostly what I wanted to show you here. One cool thing, another like really nice thing that this library does though, is you'll notice that this thing didn't actually create 2 components. It's not a with state wrapper and then list displays a separate thing. Recompose actually has Recompose has this helper called create eager element that if you are ever creating your own higher order components from scratch, this is super useful to use if you just, again, want like kind of a little bit of an easy performance win. What it basically does is it works just like React create element, except if what it's given is a pure functional component, it just calls it as a function. So it basically says my render is just you. It's not going to create a whole new element. It just calls the function with whatever the props in the state are, and that's the render output. So it's basically saving React one of those create element calls where it has to go through all the lifecycle stuff. So that's a kind of like a nice little utility. I don't think I would have time, since I did cheat and restart this timer, to actually go through and walk through kind of creating your own like higher order component from scratch. But I do think, again, I would emphasize Recompose is a really nice library for if you do have some functional components, but you want to get performance wins or just write some like pretty easily either reusable or copy pastable state enhancers for those components. This is a really nice way to do it where you don't have to write like an entire component class just to handle that one state. Cool.
Question?
Does the order in which you run them within Compose matter?
Yes. So they will get called. So if we look at here, so you see like this with handlers one is on top. That's going to end up being the outermost parent, the highest level component. So if I was to move this here, this collapsed property that I'm like calculating and passing in would actually be available here, and instead of calculating again here, I could just do that, because now I have it because I just changed the order. So yes, it does matter. Yes, it's important to keep, you can take advantage of that, but yes, there's also a downside in the sense that you might have like downstream enhancers that are trying to call methods from like 4 enhancers ago, and so you can get sometimes just tight coupling in your, you know, enhancers.
Cool.
Cool.
Let's give one last round of applause to Yoel. Awesome. Well, that pretty much concludes the evening. I just wanted to give a quick thanks to everybody who kind of showed up early and helped set up chairs and bring all that stuff in. I do apologize for the lack of space and all that. Like I said, this was the largest meetup we've had here yet that I can recall. So appreciate everybody sticking around, and if you could please help us kind of gather up some chairs and put them back in the right places, that would be much appreciated as well. But yeah, that pretty much does it for tonight. So have a good rest of your night and safe travels home.
Thanks for putting everything together. Yeah, I was lucky. I'm actually like only in town this week. Really? Yeah. I'm working like semi-remote these days. You're working what? So like semi-remote. So, oh, I see. Yeah. So you walking around the comments the other day. I was like, sure enough. Appreciate it.